MBA633 instructional video prepared by Professor Amit Datta, School of Management, George Mason University. In this instructional video, we will be discussing measures of variability. We've already seen measures of location in the data. So this is another type of descriptive statistic that is computed for a particular variable. And essentially here we want to get an idea of the spread of the data, because just knowing the middle or the third quartile, second quartile doesn't give the whole story. For instance, if you have two pharmaceutical companies producing aspirin pills, and let's say both have bottles with say 350 milligram aspirin pills, which means that the active ingredient in the pills on average should be 350 milligrams. So let's assume that the first company produces aspirin pills and that each pill has exactly 350 milligrams of aspirin. The second company also produces aspirin pills, and some of the pills have 100 milligrams of aspirin, some have 500 milligrams, others have 400 milligrams, and some others have 200 milligrams. So the second company, its pills on average also contain 350 milligrams of aspirin, but clearly that's not a desirable situation. So the first data set, if you were to measure the amount of aspirin in each of the pills, would consist only of 350. All the values would be 350, so there is no spread. So the mean is 350 and there is absolutely no spread in the data, which is good. In the second case, you would have aspirin pills all over the map, in terms of 100 milligrams, some 500 milligrams on the other. So on average again is 350 milligrams, but that's not a very desirable situation for customers, and clearly that data set has more, that variable has more spread. So here we are trying to compute, quantify measures of variability. How spread out are the values? And some measures are easier to compute than others, but they have their weaknesses. The two simplest metrics, if you will, the first one is the range of values. So, and the range is defined as maximum minus minimum. But clearly, that gives you an idea of the spread. So, in our case, let's do the calculation. The maximum value that we have, again, this is the monthly salaries for 111 students. The built-in function for maximum is max, and we'll compute the maximum salary for the 111 students, so $5,650. The minimum, the built-in function is min. I would compute the minimum. And so the range would simply be the max minus the min. So it'll be the maximum minus the minimum, which is $3,410. So that's the simplest measure of spread, the range. But as you can see from how we computed it, it's again very sensitive to extreme values. So if all the values are bunched up together, but just the ones at the end happens to be outliers, then you'll get a very distorted picture of the spread. So it's not a very robust measure in the sense that it doesn't include all the values in its computation. So it's less accurate in telling you how spread out the values are. Another metric that's used quite commonly is what's called the interquartile range, and it's defined as the third quartile minus the first quartile. If you remember how quartiles were defined from our earlier discussion on measures of location, so it's simply Q3 minus Q1. And the logic here is that in most cases, in practical situations, data values tend to be somewhat bunched around the middle. So if we have most of the values concentrated in around the middle, then the third quartile minus the first quartile is a more accurate estimation of where bulk of the values lie, rather than going out to the extreme ends as you did for the range. So let's compute the third quartile. This time I will use the built-in function, the third quartile. So I highlight the data values. So here's my third quartile. is 4025. You can see here that I've put in the range and the number 3, meaning I want the third quartile. And now I will compute the second quartile, so equal to quartile comma 1, because I want the first quartile. So there you have the first quartile, there's the second quartile. The difference between the two, third minus the first, is $860, is the a measure of the spread. So that's so you can see it's very different from the range. Okay, so the the interquartile range is somewhat better, more robust than the range, in the sense that it is not so badly affected by just the lowest or the highest value. However, the metric that's used most commonly as a measure of variability is something called the standard deviation, which is closely related to the variance, and it gives you an indication of how much the values are spread around the middle. So the standard deviation is an indicator, hence the word standard. So how spread out are the values around the middle, in this case the middle being the mean. Okay, so if we want to get an idea of how far the values are spread about the mean, then let's first compute the mean. I'll first show you the longhand way how to do the calculation, and then we will use the built-in function, so that when you do use the built-in function from then on, you will know exactly how the computations are done. So let's first compute the mean, that's the middle, and as you know, the built-in function in Excel is the average. So I will simply highlight the entire data set. Okay, so the average is $3,640. So what I'm going to do is I'm going to take each value here, each salary, and subtract it from the middle. In other words, how far is the value from the middle? Okay, so here I subtract it from the middle, and I made this value absolute. Okay, so the first value is $310 below the mean, and now I'm going to square it. The reason I'm squaring it is to get rid of the sign, because values that are above the mean are just as spread out as values above the mean. So I don't want the sign to get into the way, so the best way, or rather a good way to get rid of the sign, is simply to square it, because then the product of a negative number gives you a positive number. So let me just copy this formula over to all the other values. Oops. I have to first finish copying these. Okay, so I have the squares now. So each cell over here in the first column is simply how far the value is from the middle, and then the corresponding value to the right is the square of the value. So let me sum up the squares. So this is the sum of the squared deviations. So how far are the values away from the middle? We squared them and added them up. Okay. So let me just copy so the sum of squared deviations is simply this. We'll just compute it. The number of values, as we know, is 111. Okay, so the variance is simply the average of the two. So what is the average squared deviation? The sum of squares divided by the number of values. And the standard deviation is simply the square root of the variance. Square root of the variance. Okay, so $648 is on average how much the salaries are away from the middle, the mean, $648. Okay, now let's use, you don't have to compute these things in such a long drawn out fashion. There is a built-in function in Excel called standard deviation that will do the same calculation for you. So I'll simply say stdev, and I'll just highlight all 111 values. And it gives me the standard deviation. Now you can notice that it's slightly different from what we computed manually, and I'll tell you in a minute why that difference occurs. But let me show you the built-in function for variance also, which is var, and I highlight the same values. You go, and again you can see it's slightly different. It comes up with 424847, whereas what we had come up with manually is 421019. Okay, now to get the two exactly the same, what I'm going to do is reduce the number of values by 1. So we know there are 111 students. I'll just subtract it by 1. Subtract 1 from it. Okay, and as soon as I do that, you can see that what the manual calculation that I did is exactly the same as what the built-in function gave me, both for variance and the standard deviation. For now, don't worry about why we did the n-1, why we reduced the 111 by 1. Let me just tell you, it has something to do with calculating the standard deviation or the variance for either a sample or a population. Since we haven't yet made a strong distinction between what's a sample, what's a population, we haven't gotten to inferencing yet. Don't bother about the difference, but I would ask you to so what Excel does with the built-in function is it computes the standard deviation and the variance for a sample, and that's why it divided by n-1, the number of values in the data set minus 1. But I hope you saw manually how the calculation was done. The basic idea behind standard deviation is that it tells you on average how far the values are away from the middle. So higher the standard deviation, the higher the spread. So there is one other metric, the coefficient of variation, which is simply the standard deviation divided by the mean. So here's the standard deviation divided by the average, which was, I believe, over here we had computed. Here's the average. It's a non-dimensional, it has no units, like the average in this case would be in dollars, the standard deviation would be dollars. The coefficient of variation has no dimensions, and it normalizes for the units that I used, and it gives you an idea of the relative spread of values in a for a variable.